So now we're at question 4. Question 4. Calculate delta G at 375 for this reaction from the values of delta G, delta H, 298. This is a classic derivation. You get a nice formula in a box. You can look in your notes for this, but basically you can look up the delta G at 298. So if I'm not mistaken, a lot of times you'll have delta G2 over T2 minus delta G1 at T1 equaling delta H one over T2 minus T1. So you got to make sure that your second temperature here matches this position, not that one. So it's almost like I want to know what delta G at a second, and so it doesn't matter whether, as long as you make the 1s and the 2s match up, but I'm going to choose my second vet one to be delta G at 375 Kelvin divided by 375 Kelvin minus the delta G at 298 divided by 298 Kelvin equals whatever delta H is minus 1 over 375 Kelvin minus 1 over 298 Kelvin. So what do we know? We want that one. This one at 298, you can calculate that from the back of the book, just like you calculate this one at 298. So delta H, you know the reaction, you go to the back and you look at your delta HFs, your delta GFs for the reaction that you're given. Product, subtract reactant, so you'd have 2CO plus O2 goes to 2CO2. So you find this value, this one, this one, this one, this one, this one. These are 0, by the way. Product, subtract reactants. So this one would give you the delta H at 298. This one right here would give you delta G at 298. So you have that one, you have this one, you got these numbers, you solve for that, and you call it a day.